Newton's law of motion, practice problems. And this problem that I'm going to show you is the problem number 9. So problem number 9, try to cover certain sections so we can kind of go over the steps. So problem number 9, Chi, 35.2 kilos. So that's mass of Chi. So again, as you read the problem, you start to build your table. No structure, no sequence, just a table, data table to record all the information that we have on this practice problem. So Chi is swimming along at 2.23 meters per second. So when you see this unit, meters per second, so you write here and you think, okay, so what is a variable that I have the unit meters per second? That will be your velocity. So when she runs out of gas and coasts to a stop after traveling 3.11 more meters. So here we see a section, 3.11 more meters. So which means that she starts with this speed, 2.23, after this length, 3.11, so she stops. So the final velocity is 0. So now it's asking what force did the water exert against her. So that is a diagram kind to represent the story. So here we have the swimmer, Chi, that is swimming on this water, and that is the force that the water is applied against her. So we are going to start with writing Newton's law, because here we have a force and we have motion. So the formula that combine both fields, motion and forces, is Newton's second law. So F is equal to ma. So my A is the change in velocity over time. So which means the final velocity minus initial velocity over time. And then we stop and we look what we have as information. So do we have the force? That's what we need to calculate. We have the mass in kilos? Yes, we do. We have the final velocity? We do. We have initial velocity? Yes. But we don't have the time. So unfortunately, we need to stop right there, because this formula is not going to help to find the force. So now we need to look our data table, our motion equations, the selection that we have that we can use to calculate this acceleration with the information that we have. Okay, so if you look here, we need time. We don't need time on equation number 3. So VF squared is equal to VI squared plus 2AD. We have everything, so we can calculate A. So now we are going to select this formula and replace all the variables that we have in this data table. So we are using this formula here. Our VF is 0, VI is 2.23, and 2A, and the distance is 3.11. So and then we are going to square this number, so we get 4.973. We are going to multiply 2 times 3.11, and you have a 6.22. Now we need to eliminate this guy, so we are going to do minus 4.973 minus 4.73. So we are applying on both sides of the equation, so we can eliminate this, and our result will be 4.973 equal to this one, because this 2 is going to be eliminated. So what is left is 6.22a, and what is left here is minus 4.973. Now we divide both sides by 6.22. We cancel. And now our acceleration is, when you plug in your calculator, you should have 0.8 negative. And it makes sense because it's decelerating. The velocity is decreasing. Okay, so now what we are going to do is we need to find A. So we need to go back. We need to go back to our original formula, which is F is equal to ma. So our m is 35.2, and our acceleration that we just calculated is negative 0.8. So you do your multiplication, and the force that is exerting against the swimmer is negative 28.16 newtons. So it's negative is because it's going against with the motion that is in this direction. Problem number 10. Bob is pushing a 225 Newton wheelbarrow at 1.22 meters per second when he exerts a force of 165 Newton on the wheelbarrow. So we need to identify what type of forces this problem is talking about. So the first one, 225 Newton wheelbarrow, it gives the impression this is the weight of this object. The second force, it says very clearly that he exerts a force of, so that will be your applied force. He exerts a force of 165 Newton that's going to push this wheelbarrow. Okay. And then the problem says that when he does apply this force of 165 Newton, this object is going to start with a velocity of 122 meters per second. And is asking after how many seconds must he push a wheelbarrow to increase its velocity to 3.09 meters per second. So in other words, what is the problem is asking, what is the time required for this shift in velocity? And shift in velocity is acceleration. So this diagram here kind represents the story. So we are going to represent the wheelbarrow with this box. So we have here a weight of this box, which is Fg. And we have this force, this pushing force that is Ff. Okay, so now we need to identify these two velocities. So the problem is say they start with this, and in which interval of time the final velocity will be 3.09 meters per second. So now we need to apply Newton's second law of motion, F is equal ma. So we are going to start with our first attempt to solve this problem is using the definition for acceleration, which is change in velocity over time. And then we look our table and we think, what do I have here that I can solve the problem? I have the force that is causing the motion, which is this. That's the force that I need to apply here. And I don't have the mass. The mass is not showing here, the mass in kilos. And I have final velocity, I have initial velocity, and I'm looking for the time. So looks like that I am in the right path with this equation. I just need to figure out how to calculate mass. Okay, that will be a very easy way to find masses by using the weight of the box. So the weight of the box, or Fg, is mg. Okay, so here we have the force is 225, and the acceleration of gravity, which is part of this weight formula, is 9.8. So, and then I divide both terms by 9.8. and my mass is 23 kilos. Great, now I need to go back to my original equation. So go back to this equation and replace and do all your substitutions and to calculate the value of T. So here we have the applied force is 165. That's the mass that I just calculated. The final velocity, initial velocity, and that's the time. So now I'm going to subtract those two numbers, and I have 1.87. And then what I'm going to do here, I'm going to multiply 23 times 1.87, and I have 43.01. And then I do cross multiplication here. So T 165T is equal 43.01, and that is, I have to divide both terms by 165, and that will be the time required for the shift in velocity.